Hello everyone, I am Dr. Mali and you are watching Erudite Chemistry. And today I am going to discuss a very useful trick with you. Using this trick, you can easily calculate hybridized state of an atom in a molecule. Because hybridization state is very important for us, it gives us clear idea about the shape and the geometry of the molecule. We all have gone through the hybridization state of an element in detail, but this video is all about the short trick which will help you to do the things faster way. Okay, so first of all we will understand the trick and then we will apply this trick to calculate the hybridization state of an element. Okay, so in the first step you will calculate the valence shell electron of all the atoms which are present in the molecule. So total number of electrons you will be calculating first, and whatever the answer is, I have divided them into two categories. Means if your answer is less than 8, means there are less than 8 electrons, all number of electrons present in the molecule. Okay, so if the electrons are less than 8 or 8, then you have to deal it in a different way. But if your electrons are more than 8, you have to deal it in a different way. So I've categorized them into two ways. If the electrons are less than 8, what you have to do, let's understand first. So if the electrons are less than 8 or 8, the number what you are getting, the number of electrons in the valence shell of all the atoms total. So that total, if you are getting 8 or less than 8, what you will do? You will just divide that number by 2. Once you get a number, that number after the division, whatever you are getting now, so this number which you are getting after the division, you will compare with this given chart. This chart is having the direct relationship between whatever the number you are getting. Suppose number of electrons, total number of electrons I am getting 8. So just because it is telling me that I have to divide it with 2, I will divide it with 2 and I am getting what? 4. So this is the answer of this process, and this 4 is the number of hybrid orbitals, which will give me the idea about what is the hybridization state of an element. That is, I will go to this chart, look at this, answer is 4, I will match this with this chart and I will get it that my hybridization state of an element in this case is sp3. So this way we will calculate hybridized state of an atom in case if the total number of valence electrons are less than 8 or 8. But if the number of electrons are more than 8, then what to do? If the number of electrons are more than 8, you will first divide that number with the 8. Okay, so the first step is divide that number with 8. Suppose my answer is 24, means 24 valence shell electrons are there. So if your 24 electrons are there, you will divide that number by 8. So what is the answer here? 3. So this 3 is the answer here. Means this 24 is completely divisible by 8. So there is no issue. Just get this number and compare this number with the given chart. That is, in this chart you can see that 3 is showing that it is sp2 hybridized. So there is no issue with it if the number is divisible by 8. But if you get a residue in this after this division, for an example, if the total number of electrons are 26, then what? Then I will first divide it by the 8. That is, I divided by the 8. I will cut it with 3. That is, the left out is 2. So 3 I have divided completely, and what is left out? 2, and the residue I have to divide with the 2. So this residue I will divide with 2. So the answer is 3 plus 2 by 2, 1. That is 4. So this 4 is the ultimate result, and this we are going to see in the chart then, and then we are going to decide the hybridization state accordingly. So in this case also our hybridization state of the element is sp3. So to understand it in a better way, let's do it. So the very first example is PCl5. So I am going to calculate the number of valence electrons of all atoms present in the molecule. So here we have phosphorus. The outermost shell electron of phosphorus contains 5 electrons. It belongs to the nitrogen group now. Now add the electron of chlorine atom, that is 7 electrons in each chlorine. How many chlorine are there? 5. So total number of electrons in the valence shell will be 5 plus 35 and total number of electrons will be 40. Now, just because the number of electrons we are getting more than 8, now I will divide this 40 with 8. So, I am going to divide this number with 8. And the answer is 5. And I am going to see this chart now. Look at this chart. This chart is indicating that the hybridization state of this phosphorus in PCl5 is sp3d. So you can see here that the hybridization state of phosphorus in PCl5 is 3. Next example I am taking is PCl3. In PCl3, phosphorus has 5 electrons in outermost shell, chlorine has 7 electrons in outermost shell. There are 3 chlorine in PCl3. So the total number of electrons becomes 5 plus 21, that is 26. Just because this number is more than 8, I will divide it with 8. So this is 8. So when I divide this number with 8, 3s are 24. I am getting this 2 as residue and this 3 is my answer. So this is 3 plus residue. 3 plus residue. Now the residue has to be divided by 2. Whatever the number I am getting, this will be added with this 3. So 3 plus 1. So this becomes 4 and 4 is indicating that the hybridization state of phosphorus in PCl3 is sp3. So here I am writing down hybridization state of phosphorus in PCl3. Let's take one more example, and another example is NH4 plus. In NH4 plus I am going to get hybridization state of the nitrogen. So what is the total number of valence electron? Nitrogen contains 5 electrons. One hydrogen contains 1 electron. There are 4 hydrogen. So this is the number of electron, but as you can see here, this is cation. That means 1 electron is taken from here. So I am reducing 1 electron. So the answer is 5 plus 3, that is 8. Now this time I am getting 8 electron as my answer. So how I have to deal with this number? That is, if the number are 8 or less than 8, I have to divide this number by 2. So I am dividing this 8 by 2 and getting what? 4. 4 means the hybridization state of the element in the molecule is sp3. So nitrogen in this ammonia molecule is showing hybridization state sp3. Let's take one more example here. I am taking XI-XII. In XI-XII it is inert gas. So total number of valential electron 8. In the fluorine 7 electron. How many fluorine? 2. So the total number of electron becomes 8 plus 14. That means it becomes 22. Because this number is more than 8, I will divide it with 8. So the answer comes out as 22 divided by 8. 16 and the residue is 6. So 6 is the residue, 2 is the answer. So I am getting 2 and 6. This 6 residue is going to divide by 2. So this becomes 2 plus 6 divided by 2, 3. And the answer is 5. Now this 5 is indicating that the hybridization state of the element in this molecule is sp3d. Means xenon in CF2 is at the hybridization state sp3d. So let us apply this trick to some more examples. So here I am taking this time XeF6. In xenon fluoride, hexafluoride, xenon is at 8. How many electrons are there in the outermost shell of fluorine? 7. How many fluorines are there? 6. So the answer is 8 plus 42 and total is 50. And just because 50 electrons are there, I have to divide this number because it is more than 8. I will divide it with 8. If I divide this number with 8, I will get the answer as 648. 2 is the residue. So here I am getting 6. This is the residue. Residue will be divided by 2. So this number. So the answer is 6 plus 1, that is 7. This 7 number is indicating that the hybridization state of this xenon in XI-XII is sp3d3. So this is the hybridization state of the xenon in XI-XII. Another example here is SO3, that is sulfur trioxide. In sulfur trioxide, we have 6 electron in sulfur, we have 6 electron in oxygen, there is 3 electron, there is 3 oxygen. Now 24 electrons total. Okay, 24 electrons divided by 8. 3 is the answer, and just because it is 3, hybridization state becomes sp2. Same way, I can take one more example. The last one is NO2 plus, and this species, in this species nitrogen, hybridized state of nitrogen we can calculate as nitrogen is 5, oxygen is 6, 2 oxygens are there, 1 electron is removed. So total number of electron 5 plus 11. 6 to the 12 minus 1. So this becomes 16, and the answer becomes 16 divided by 8, and this is 2, and 2 means that the hybridized state of nitrogen in NO2 plus is Sp. So I can write down the hybridized state as P hybridization state. So I hope this video will be helpful for you to calculate the hybridization state in a faster way. If you like this video, please hit the like button, subscribe it and share it with your friends. Thank you very much.